continue with this. So yesterday we have seen this particular relation delta is equal to 8.64 into B by D, where delta is the total depth of water applied to the crops. B is the base period and D is what it is the duty. So in continuation with this, now we will cover our next point. Okay, now we are going to discuss the term command area. Okay, we will see what is command area. So in short, what is command area? Command area is the area to which the water is supplied through the canal. So that is called as a command area. Command area is the area where water is supplied by gravity from the canal. So generally, when the canals are constructed, care is taken that these canals are constructed along the ridge line. In surveying, we have studied about the term ridge line or ridge point. So ridge line or ridge point is a point with highest elevation in that area. So just see this above figure. So what this figure shows us, this figure shows us one such a ridge line or ridge point. So this particular point is a ridge point, and the canal is excavated along this ridge point so that water can be supplied under gravity to the left side as well as to the right side, as we can see in this figure. So that point is called as a ridge line. And what is command area? Command area is the area enclosed between two drainage lines, natural drainage lines. Okay. So the previous slide is what? It is a repeated slide which includes the relation between the duty delta and base period. Okay. So that is a typed slide. Whereas the slide I have explained yesterday was written. Okay. So both slides are same slide. So we have already covered, that is on relation between duty delta and base period. Okay, now concentrate over command area. What is command area? Command area is the area enclosed between two natural drainage lines, and in between there is a ridge line. So see this second figure. In the second figure, okay, here it is clearly shown. It is a plan of the area, and here it is shown that at the center, this particular line is the ridge line. Yes. Okay, so this particular line is the ridge line. Okay, this particular sketch is what? It is a plan of command area. And in this plan of command area, this line is a ridge line. And above figure is what? It is a cross section of this particular plan. So if we draw a cross section here, then we get such a figure. Okay. So what we can see, this top point is the ridge point. The canals are excavated along the ridge point. Okay, they are excavated along a ridge line. They follow the ridge line, and they supplies water to the left and to the right, as we can see in this particular plan. So they can supply water to the left and right. Okay, till and they supply this water under gravity and till the drainage line. So this is the first dotted line, that indicates the left side drainage, and this is the right side drainage. So the distance between these two drainage lines is called as the command area. And in between there is a ridge line. Okay. So that is the general information about the term command area. Now in command area, there are various classifications. In that, one is the gross command area. Okay. So gross command area. What is gross command area? Gross command area is the total area which can be economically irrigated from irrigation system without considering the limitation on the quantity of available water. So gross command area is a total area. Now here the area between these two drainage lines is a gross command. Now this gross command area may consist of agricultural land. It may consist of natural water bodies in the area. It may consist of some Gauthan areas. Okay, so everything is included in this gross command area. Okay, but it is the area where water can be supplied under a gravity. So that is meaning of the term gross command area. Now after the gross command area, the next type of command area is culturable command area. Now this gross command area is having culturable command area. So what is culturable command area, which is denoted as the CCA? Culturable command area is cultivated land in the gross command of an irrigation system. Okay, and it includes all land of a gross command on which cultivation is possible. म्हणजे जिथं आपण शेती करू शकतो. टोटल ग्रॉस कमांड एरिया म्हणजे काय की त्याच्यामध्ये ऍग्रिकल्चरल लँड असेल, त्याच्यामध्ये गावठाण एरिया असेल, त्याच्यामध्ये नॅचरल वॉटर बॉडीज असतील किंवा त्याच्यामध्ये बाकीचे ग्राउंड फीचर्स. Okay, but in that case, water can be supplied to all this area by gravity. So that is called as a gross command area. And culturable command area is a part of gross command area where actually the crops are grown. That is called as a culturable command area. So it is a agricultural land where the cultivation is possible. Now this culturable command area is divided into two categories. One is cultivated culturable command area, cultivated CCA, and uncultivated CCA, uncultivated culturable command area. Now what is cultivated area? So it is the area in which the crop is grown at a particular time or crop season. In yesterday's lecture, we have discussed about the crop types and crop season. We know that there is a Rabi season, there is a Kharif season, and there may be a perennial season. So whether it is a Kharif season or Rabi season, so culturable cultivated area is the area in which the crop is grown at a particular time or crop season. And culturable uncultivated area is what? It is the area in which crop is not sown in a particular season. Okay, so that area is kept empty. That is called as a culturable but uncultivated area. Okay, and culturable cultivated means the area on which the crops can be grown and the crops are cultivated there. So that is the difference between culturable cultivated area and culturable uncultivated area. So we have discussed about these four types of command area. One is the gross command area. Second is the culturable command area. And culturable command area is divided into two subtypes: culturable cultivated area and culturable uncultivated area. So based on this, sometimes a short note may be asked in the exam. Okay, and question will be explain the types of command area or give the classification of command area. So such a question may be asked for 5 marks. Now we are going to discuss about the term intensity of irrigation. So what do you mean by intensity of irrigation? So intensity of irrigation is defined as the percentage of irrigation area proposed to be irrigated annually. Okay, suppose in a command area. Okay, so what percentage of the irrigation area is irrigated annually? That is called as the intensity of irrigation. Now we know that there are the crop seasons like Rabi, Kharif. Okay, so the areas irrigated during each crop season is expressed by the percentage of cultivable command area, which represents the intensity of irrigation for the crop season. Now, suppose the cultivable command area is cultivable cultivated area is suppose 120 hectares. And on this 120 hectares, suppose in Kharif season, 80 hectares is used for cultivation. And in Rabi season, 50 hectares is used for cultivation. Total cultivable cultivated area is 120. Out of that, 80 hectares of land is cultivated during Kharif and 50 hectares of land is cultivated during the Rabi. So in that case, the intensity of irrigation for each season can be calculated as the area irrigated in that particular season divided by cultivable command area. For example, in Kharif season, 80 hectares of land is irrigated out of 120 hectares. So 80 upon 120 into 100. So intensity of irrigation during Kharif season is 66.626%. In the same way, during Rabi season, the area irrigated is 50 hectares out of 120 hectares. So 50 by 120 into 100. So during Rabi season, area intensity of irrigation is 41.67%. Okay. Now, if we have to find out what is the yearly intensity of irrigation, then we have to take the intensity of irrigation in all crop seasons, that is Kharif season and Rabi season. So here if we add these two values, 66.66% and 41.67%. So addition of these two is 108.33%. Okay. So this is what it is called as the yearly intensity of irrigation. And we came to know that yearly intensity of irrigation may be more than 100%. Okay, because the different area is irrigated in different crops. Due to that, this is possible that the yearly intensity of irrigation will be more than 100%. Okay. So after studying about the intensity of irrigation, now we are going to discuss about various factors which affects the duty. Okay, so this is the list of factors affecting duty. So in that, the first one is methods. First one is methods and systems of irrigation. So at the beginning of this lecture, after studying what is irrigation engineering, what are the benefits and ill effects of irrigation, we have discussed about the systems of irrigation. So which are the systems of irrigation? So there are two main systems of irrigation. One is flow irrigation and other is lift irrigation. So if we compare these two systems of irrigation, then in flow irrigation, the length of canal is more, and that's why the duty will be less. Opposite to that, in lift irrigation scheme, the water is lifted by means of rising means with help of pipes. So the conveyance losses are less, and that's why the duty will be higher. So if we compare these two systems of irrigation, then it is clear that in case of lift irrigation scheme, the conveyance losses are less, and that's why it is higher duty. So that is the first point. Okay, factor, which is the factor systems of irrigation or methods of irrigation. The second way, the second factor is mode of applying water. So in previous lectures, we have discussed about number of methods of applying water to the ground. So we know that there is a furrow system. We know that there is a flood irrigation system. We know that there is a sprinkler irrigation system and subsurface irrigation system like the drip irrigation. So in drip irrigation and sprinkler irrigation system, now in this particular mode of applying water, the optimum use of water is done and there is a saving in irrigation water. And that's why if such a methods are used, it results in higher duty. Okay. And for economy, the duty must be high. Means what? Within 1 cumex of water, maximum area should be irrigated. So in case of this advanced mode of applying water like sprinkler irrigation and drip irrigation, the duty will be higher. Opposite to that, in case of flood irrigation system, the duty will be lower. The third factor is the method of cultivation. Okay, so which method of cultivation is adopted? So if the land is properly plowed and it is made quite loose before irrigation, then that soil is having good tillage and it can hold water for longer duration. And that's why the duty will be higher. So that is the meaning of term mode of cultivation. Okay. Next is time and frequency of tilling. So what is tilling? Tilling is the term tilling is related to the tilt of soil. So tilling म्हणजे काय तर मराठीमध्ये मशागत करणं. ओके. आणि टिल्ट मशागत केल्यामुळे जमिनीचा जो पोत सुधारतो. Okay, that is called as a tilt. Okay, so this tilt is defined as it is the internal arrangement of soil particles which is improved by tilling operations, various tilling operations. So if the tilt of the land is good, in that case, the water is retained for longer duration and frequency of irrigation required will be less, and hence the resulting duty will be high. Okay, so time and frequency of tilling, how many times this tilt is maintained. Okay, so that is important. So if tilt is good, in that case, it yields higher duty. Next is the type of crop. So we know that some crops need maximum water. Okay, like rice, like sugar cane. We know that the delta for rice is 120 centimeter. For sugar cane, it is 90 centimeter. So here the water requirement is higher and which results in lesser duty. If the crops need more water, then duty will be less. If there is a crop like the gram, so in that case, a very less quantity of water required. So in that case, duty will be high. So based on the type of crop, this duty is varying. Next is the base period of crop. We have discussed about the term base period. It is the time taken between the first watering and last watering is called as a base period. So if base period of a crop is more, then naturally more water is required. And if more water is required, means the duty will be low. Okay. So if the base period of the crop is less, in that case, duty will be high. The duty is also affected by the climatic conditions of the area. So if the temperature is high, wind velocity is more. If you consider the climate factors like temperature and wind, then they accelerate the rate of evaporation. Evaporation will be increased. And due to that, what happens? Duty will be decreased. Opposite to that, if the humidity is more in the atmosphere, in that case, there is a less chance for evaporation of water. In that case, duty will be higher. So this is how the climatic conditions of the area affects the duty. Next is the quality of water. So if the water contains some harmful salts, in that case, the more water is required to be applied. Because when the more water is applied, these salts are leached off. These salts are drained out from the area. So as more water is required, if the quality of water is not good, in that case, the duty will be lower. And if quality of water is good, the duty will be higher. The next factor is method of assessment of water. Now, what do you mean by assessment of irrigation water? So, assessment of irrigation water means charging the taxes to the farmer or collecting revenues from the farmer for using the irrigation water. So, there are two methods of assessment of water. In that, one is the area-based assessment. So, how much hectare of land is registered? So, based on per hectare, some charges are there. So, in this particular method, there is no control over the volume of water used by the farmer, because here this assessment method is based on area to be irrigated. So, in that case, the duty will be lower as use of water is high. Opposite to that, if volumetric assessment method is used, where the farmers are charged based on how much volume of water is used. So in that case, the duty is higher because farmers know that the charges are as per the volume of water used. So they will try to use the optimum water, and that's why duty will be high. The next factor is canal condition. So if canal conditions are not good, means canals are not lined, protection is not provided. So in that case, there will be more percolation. So there will be more conveyance losses. And that's why water to be supplied is more, and hence duty will be low. If canal conditions are good, if they are lined canals, then there are less losses due to percolation. So duty will be high. Next thing is regarding the length of canal. If length of canal is less, in that case again conveyance losses due to percolation as well as due to evaporation will be less, and hence duty will be high. Characters of soil and subsoil of the canal. So we know that these canals are constructed either in cutting or in embankment. So whether it is in cutting and if it is passes through the rocky strata, in that case the conveyance losses are less, and that's why duty is higher. And if the soil consists of the coarser particle, if it is a sandy soil or coarse grained soil, in that case percolation losses will be more and duty will be less. Next is the character of soil and subsoil of irrigation field. Just now we have discussed about the character of soil and subsoil in the canal. But now we are talking about soil and subsoil in the field. Okay. So in the irrigation field. So if the soil is coarse grained soil, then naturally the more water will drain out from that area. And suppose up to 1 to 2 meter, there is a coarse grained soil, and after that, there is a hard pan. Okay, after that, if there is a hard rock, so in that case, there are less chances for percolation of water, and hence resulting duty will be more. Okay, now we are going to discuss about how to improve the duty. Now it is clear to us from the factors affecting duty that duty should be higher one. Okay, so 1 cumex of water should irrigate the maximum area of land. So that is meaning of duty should be higher. So how to improve the duty? So that is the point. So in that, the first point is suitable method of applying water to the crops should be used. So we know various modes of applying water to the crops. So if we use the drip irrigation method or sprinkler irrigation method, duty will be high. Then we know that if the land is having good till, then duty will be higher. So this is the second point. If the land is properly plowed and leveled before sowing the crops, it is having a good till, and hence the duty will be higher. Next is the land should be cultivated frequently. Since the frequent cultivation reduce the loss of moisture, especially when the ground is within the capillary reach of ground surface. The canal should be lined one. We have discussed what is the importance of lined canals. Lined canals means what? To the canal bed and to the side slopes of the canal, protection is provided in terms of concrete. So that is a lined canal. So this reduces the percolation and seepage losses. Also, the water is conveyed quickly, thus reducing evaporation losses. Then if the full supply level of the canal is higher, in that case, the conveyance losses are more. So it is suggested that instead of a single canal, 2 canals should be running side by side so that the full supply level of the canal is low, and which reduces ultimately the conveyance losses, percolation losses, as well as evaporation losses. So that is one of the way to improve the duty. The ideal length of canal should be reduced. So while planning the conveyance system, the length of canal should be minimum. The alignment of canal in sandy soil and fissured rock should be avoided. So if it is a sandy soil, means it is a coarse grained soil, and if it is a fissured rock, means there is a more chance for percolation. So alignment through such a soil should be avoided. The canal should be aligned that aligned that the area to be cultivated are concentrated along it. So the distance between area to be cultivated and the canal should be less. The source of supply should be such that it gives good quality of water. The quality of water should be good. So we have just discussed what is the importance of the good quality of water. The rotation of crop must be practiced. Okay, crop rotation is important. If proper crop rotation is there, in that case, it yields in higher duty. So for one example of crop rotation is if the groundnut is taken, then in Kharif season, then in Rabi season, the next crop should be either wheat or gram. So in that case, more yield is get, and also the water requirement is less. So the next way of improving duty is use of volumetric method of assessment. Then training to the farmer is essential for proper use of water so that they can use the water at correct timing and the optimum quantity. Now there is one more suggestion to improve the duty. The land should be redistributed to the farmers so that they get only as much as land they are capable to manage it. Okay, so this is quite difficult thing, but this also reduces the duty. If there is more land for one farmer, then he is unable to manage all the land, okay, for irrigating that particular land. Then research stations should be established in various localities to study the soil, the seed, and conservation of the moisture. The canal administrative staff should be efficient, responsible, and honest. Okay, so some peoples are appointed to check whether someone is stealing water from the canal. So this canal staff, administrative staff, should be efficient. They must be responsible and they must be honest. The operation of canal should be such that farmers both at the head as well as at the tail end get water as and when they need it. So in the command area, every farmer should get water. So that depends on the regulation of the water from the canal, and that is done by the administrative staff of the canal. So they must be efficient, responsible, and honest. Okay. Now we are going to discuss about some of the definitions. In that first is the core period or core depth. The term core period or core depth is used to describe the watering given to the crop when the plants are still young. Okay, it is usually the maximum single watering required, and other waterings are done at usual intervals. So that is called as a core period. There is a term paleo. So what is paleo? In the initial stages, before the crop is sown, the land is very dry. In that case, the soil is moistened with water and then the crops are grown. That is called as the paleo irrigation. There is a term outlet factor. The duty of the water at the outlet, that is at the turnout leading from the water course and the field channels on the field, is known as the outlet factor. There is a term time factor. Time factor is the ratio of number of days the canal has actually run to the number of days of irrigation period. There is a term capacity factor. Capacity factor is the ratio of mean supply to the full supply of a canal. Then there is a term Cumex day. So what is Cumex day? The quantity of water flowing for one day at a rate of 1 cubic meter per second. That is called as a Cumex day. And if we calculate what is the total volume will be there, then it is equal to 8.64 hectometers. Hectometer is a unit to represent the volume of water which is collected in one day with a rate of 1 cubic meter per second. If the discharge is 1 cubic meter per second and the supply is for 24 hours, then total volume of water supplied is 8.64 hectometers. There is a term nominal duty. The nominal duty is the ratio of area to be irrigated for which permit is given for number of days to the mean supply for the base period. There is a term full supply coefficient. It is defined as the area estimated to be irrigated during the base period divided by the designed full supply discharge of the channel at its head during maximum demand. It is also known as duty on capacity. Okay, root zone depth is the maximum depth of soil strata in which crop spreads its root system and derives water from the soil. Okay, so with this, here today we'll stop here as and in tomorrow's lecture, we will solve problems based on this. Okay. So today we'll stop here. Now the last point is left, that is problems on calculation of reservoir capacity. Thank you.